All right, so let's talk about going from the skeletal to the chair structure when we have multiple substituents. So let's draw a cyclohexane, this time with multiple substituents. So we'll put two methyl groups, right? These are two CH3s. And we can see that in this case, they're both wedges. They're both wedges. And so what we say here is that they're both up. And so let's go ahead and draw a cyclohexane picture, or a chair picture of this. Right, and so we'll just arbitrarily select this carbon to become this carbon. And so we have two positions, right? We have the axial going over here, and then the equatorial going over here. Well, if we're thinking as our methyl group as up, we should put it up here, right? So it's going to occupy the axial position. Then we'll arbitrarily make this carbon over here. And then we think again, there's two positions. There's this axial, and then there's this equatorial. But in this case, it's the equatorial that's up. And so since we have a wedge, this one should be equatorial. And so you can see both of these methyl groups are up, whereas the hydrogens are down. So up or down does not mean axial or equatorial. It really depends on the situation. And then we can, of course, think about doing a ring flip here. This carbon over here is going to come on up. This carbon over here is going to come on down. And everything will be shifted one over. Draw our lines facing the opposite direction. Connect them over. And now we think about this carbon over here is now this carbon, and the axial and equatorial positions have flipped. And so this methyl group was equatorial. Now it is axial. And then following along, this carbon over here is now this carbon right here. And this axial CH3 is now an equatorial CH3. Whereas now the hydrogen is axial. And you can see in this case, still both of these methyl groups are up. And then if we think about the steric strain in these ones, it's the same. They're both the same energy because we have in both of these structure one equatorial methyl group and one axial methyl group, right? So in this case, they're the same. One of these is not going to be favored over the other. Let's take a look at another cyclohexane. So in this case, we're going to again do a dimethyl one. So we'll have a CH3 here, except this time we'll draw a dash over here, right? So this CH3 we're going to say is up, and this CH3 is going to be down. Technically, it doesn't have to be up or down, because you can chair flip it, but it just needs, you can rotate it 360 or 180 degrees, but it needs to make sense, right? All right, so let's go ahead and draw the chair conformer of this. And again, we're just going to arbitrarily decide that this carbon is going to be this carbon. And so we can see this CH3 is up, and so we need to put it in this axial up position. And then we're going to designate this carbon to arbitrarily be this carbon. And now this methyl group is in the down position. The down position here is also axial, right? So they're both axial in this case. And then, of course, we can do a ring flip here. So this bottom carbon is going to come on up. This carbon over here is going to come on down, and everything's going to be rotated one spot over. And so, right, this carbon over here is now this carbon over here, and this axial methyl group now becomes an equatorial methyl group. And then this carbon over here becomes this carbon over here, and this axial methyl group now becomes an equatorial methyl group. Draw that in purple. And so we can see these two are conformationally different. In the top image, we have two axial. In the bottom image, both of our methyl groups are equatorial. And so this bottom one is going to be favored due to less steric strain.